I've been making treadmill motor videos now for a couple of years, and in that time, there have been a lot of questions. There is one question that comes up over and over and over again. In case you missed it, I've been asked this question a lot.
Greetings, fellow DIYer, and welcome to my video.
And it all comes down to that device right there. That is a capacitor. That is a resistor. This combination together is better known as an RC circuit. And the question I keep getting is, can I attach a capacitor to the power supply that is powering my treadmill motor as a way to clean the power? And on the surface, the answer is yes. So let's take a look at this a little bit. First of all, why would you want to use something like this? What happens with a capacitor is it basically holds a charge and discharges a charge. What that means for the sake of running a treadmill motor is it's more likely to absorb power spikes, and it's also more likely to provide a consistent, even flow of electricity. That all sounds like good things, and that's why people have asked me if they should add a capacitor to their setup. I had a circuit just like this on 3 of my machines. I had it on the mill, I had it on the lathe, and I had it on my bandsaw. And the problem that I found when running one of these was there was definitely surging when under a load. So if I was single point threading on my lathe and there was a lot of tool pressure and things were beginning to bog down a little bit, I would get kind of a pulsing and a surging. And basically what was happening was the capacitor was discharging, trying to help smooth out the load. But the result was basically a less than consistent spindle speed. And so that's why I removed them from my machines. The other thing that I didn't like about the capacitor is when you turned the machine off, it still needed to discharge. And that would result in the spindle spinning just a little bit longer. If you look at my other videos, I have a whole series on an electric braking resistor that allows you to stop the spindle faster without any damage to the motor. And running something like this would be counterproductive in that case. Now, I'm not saying you shouldn't run one of these. I'm just saying that my experience when running them was less than positive. But you know what? I'm not here to make your decisions for you. I'm here to give you the information and let you make decisions for yourself. So, on the off chance you actually want to run one of these, let's break it down, figure out what I did, how I got it, and then you can make an informed decision. As I said before, we have a capacitor and a resistor. And the reason these two things are in parallel is, as I said, the capacitor holds a charge. When the system is turned off, the capacitor still holds a charge. And if you were to touch those two terminals right there, you would get shocked. But by having a resistor in parallel to this capacitor, it will slowly dissipate the electrical current in this capacitor and basically drain it. So that's why you oftentimes see a capacitor and a resistor in parallel in a setup like this. Now, this is not something that is ready-made. I'm sure there are places out there that do sell RC circuits ready-made, but this was actually harvested from treadmill motor parts. So if you look at this MC2100, we have a capacitor, and right next to it, we have a resistor. And then we have the 2 leads that the current comes out of when using a system like this to power a treadmill motor. That's exactly where this came from. This was a circuit board that was in an existing treadmill. The circuit board was not functioning. This came from an MC2100 that did not work. There are similar setups in treadmill motor boards that can't easily be hacked. And all I did was remove all the extraneous components, cut out this section, and then I used my multimeter to make sure that I had continuity from the positive terminal to the positive side of the capacitor and from the negative terminal to the negative side of the capacitor. Now, capacitors are always marked. See that right there? That means that that's the negative side. And once I knew I had that continuity, then I can just simply put wires coming off of these two spades so that this can be wired in parallel with the power coming out of the power supply and going to the treadmill motor. By removing all the components and cutting this down to size, I lost the connection between the negative side and the terminal. But that was nothing that a heavy-duty piece of wire couldn't fix. With all this in mind, if you've parted out several treadmills and you have a board that you can't use, there's a good chance that there is a circuit like this on the board. You'll know that the capacitor in it is rated to work with a treadmill motor. It may not be the perfect rating for your treadmill motor, but it's likely going to be close, and this is an option to harvest that circuit. As I said, I was less than impressed with how this functioned with my setups, but that doesn't mean that it won't work for yours. If you have any questions, please don't hesitate to put them in the comments. That's how this video came to be. Lots of people have asked about adding a capacitor, and so now I've put together a video on adding a capacitor.
If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.